I honestly, I remember having conversations like, what does environmental engineering do? Like, I had no idea. So I would look into that.
Hi, my name is Emily Marvin. I'm an environmental engineering major at ASU, and I currently work in the private sector for a manufacturing industry. Day to day, as an environmental engineering intern, I do a lot of learning. I think first and foremost because there's a lot that you need to learn, especially if you're going into industry, because a lot of the environmental permits or rules and regulations are very industry specific. So a lot of my time is spent learning about how these rules made by the EPA or Arizona Department of Environmental Quality, how they are altered to fit us. And then outside of that, I complete a lot of compliance documents. I go out on our site and I check the hazardous waste drums and the wastewater treatment plant and our air scrubbers, and I go and make sure that everything is within compliance so that we don't get fined by the government. I would say if when trying to get an internship, apply to everything because you never know what you're gonna get. And some of your rejections, it's not personal. They just maybe they found somebody else or this or that. I think I applied to 40 different internships, got rejected from many, but then a couple stuck, and then I decided to go with the one I'm at now. So I would say apply a bunch. And then another piece of advice I would say is go in confident. I think a lot of the times we feel not so confident because we just have our school knowledge and everybody else is older, more experienced, knows what's going on, but they hired you for a reason and they want you to be there. So, be grateful you're there, learn as much as you can, and go in confidently.
Yeah, so we generate wastewaters that have metal concentrations in them. So we're looking at copper, nickel, chrome, silver, and we also generate cyanide-bearing wastewaters. And so before those wastewaters can go back into the general public, to the sewer, we have to make sure we pre-treat to standards so that the treatment plant down the road, so say 91st Avenue or there's 23rd Avenue as well, they can take that and not be out of compliance with their permit. So my main responsibility is I manage certain environmental programs at our facility. So I focus on wastewater and hazardous waste. And so my job is to go out and ensure that we collect the right data, that we meet our reporting requirements, that we follow all aspects of our permits and the rules and regulations of the state of Arizona. And then I also coordinate different projects from the facility level. So I'm looking at repairs for our sites, looking at capital projects, and coordinating those from start to finish.
I am responsible for all of the environmental health and safety compliance as well as facilities operations at the plant. So like Andrew mentioned, not only hazardous waste or RCRA compliance, but stormwater. We have hex chrome plating operation, so environmental compliance. We also have jet engine testing going on there, so lots of Title V permitting compliance, as well as all the safety, so machine guarding, hazardous energy control, all the safety related programs, and health. So making sure that once somebody gets hurt, we take care of them, we have the right nursing staff. We do environmental compliance or monitoring for radiation exposure, dust, doing testing for respiratory protection and fit testing, just everything at the facility.
So we work together with the city to make sure that we're treating our wastewater to their standards, then they can treat it to the state standards. So a typical day, I would say, starts with a morning meeting. We kind of all get together and discuss escalations for the site, issues we're dealing with, things that are going on that we all should know about. we have a list, an online tracking system for all of our compliance obligations and action plans that we take care of. So we use those to kind of help keep us accountable for getting our tasks done throughout the week. We also have, emergencies that might pop up that we have to go deal with right away, requests from the plant manager, requests from the directors, and so we kind of have to prioritize based on what are the events of the day, what has to get done. So it can be a lot of sitting at your desk, or it could be that I'm standing, all day and I'm running around the plant and I'm just checking things, taking pictures, calling in contractors to assist, and then cataloging that, getting that work done, and then reporting out.
Recently, so we're working on a Title V permit revision, short-term revision for a minor permit modification, and then a major permit modification down the road. As far as normally, it's just you're maintaining compliance with permit conditions, but when you're manufacturing and your company wants to increase the throughput of the jet engines that you're testing, you've got to get enough emissions, allowable emissions, so you can test those pieces of equipment. For us, it's NOx, and so right now we're going through the process to evaluate how much NOx are we going to need, and then requesting that in our permit, figuring that out, and doing emissions modeling with consultants to come up with how much we think we're going to emit, and then also looking at ground plumes as far as how high the stacks need to be in order to keep that from interfering with the local community. So it's what can we substitute or eliminate first, and or if not, then substitute. And if not, then how can we change our process? For example, in plating, not having drag out. If you pull parts up and you're taking it from tank to tank, you've got drips, and those drips, if the company you're working for doesn't have drip preventers or pieces of metal that keep the drips going back into the tanks where they came from, then you'll drip that between the tanks, and that'll accumulate, and you're generating unnecessary waste underneath the tanks.
I got some great advice from a professor back when I was in college, and it was to take chemistry classes. So more than the recommended amount for environmental. So for me, when I was in my bachelor's degree, I took I think 2 courses of general chemistry, and then I went on to take organic chemistry and another analytical class to kind of help me with my lab skills, because there's a lot more chemistry in environmental engineering than you kind of might realize. So water chemistry, air, atmospheric chemistry, understanding the different waste disposal processes, land disposal restrictions, all that has a chemistry aspect to it. And so having that kind of stronger background in chemistry will really be able to help you in a career, because you're able to speak to, okay, so why do we need, or why does this large amount of NOx impact air quality, and how does that with especially here in Phoenix, we're in a big valley, right? So a lot of times we can have some sort of a plateau where air emissions can't disperse, they're kind of blocked, right? And so being able to kind of go through and discuss more of that can really set you apart. I'd also recommend, as you're going through your classes, to really focus on Excel and finding ways to kind of help Excel work for you rather than you trying to work with Excel. Excel has a lot of great features, allow you to crunch a lot of data quickly, and so spending less time in Excel and having more accurate data is going to help you long in your careers. I would also say, try to get as much experience as you can in many different fields. That's why when I started with consulting, it was really great because I was able to see all the different types of industry, deal with regulatory agencies, and kind of understand, okay, where do I think I might fit in best here? Is it in consulting, or is it in industry? And so there's more than one way to do it for sure, but there's a lot of cool places to work out there, and a lot of cool opportunities. So.
And I would say, never be finished with your education, or never be satisfied with your education. I'm still taking classes, getting credentials. I've been doing that my whole career. No one's been giving it to me. I've just been going and doing it on my own. It's super critical in order to be successful. If you want to advance in this type of field, the more education you can get, and the more education you have, the more credible, and the more weight you can hold in conversations. Exactly. We're going to increase our throughput, our production, but we need you to offset our carbon emissions to net zero by 2035. So how are we going to come up with what type of technologies are we going to have to come up with? People agree to those requirements, but don't have any idea what it takes to get there. So as we generate, we have new engines, I guess you could say, coming through into the process. Now we have to offset that footprint. So how are we going to do that? Through wind, through solar, carbon capture, and with that, that's a significant technology that we would have to introduce. So just thinking about that, thinking about different ways to be able to handle emissions as well as how to cut down. So what technologies?
Hi, my name is Mackenzie Steele. I'm a junior as an environmental engineer, and I've been working as a research aide for it's going to be 2 years in this January, where I looked at like nutrient recovery of like phosphorus from urine. And how we did that, we did through like precipitation reactions. And this is actually where all my chemicals are at that I would use. And so we got like 12 different unique precipitants, and we would measure it afterwards each time. We would look at the concentration to see how much phosphorus was removed. We would put it on a shaker table, which is right over here. And it's pretty simple. You just put it in here, they slot in, and then you just set it for a timer. We would run it for an hour, and once we do that, we would take it out, we would measure the pH with a pH probe that's very similar to something like this. And once we did that, we would have to filter our samples, since we would then run it through a spectrophotometer, a UV vis. I use a fancier one that's not in this lab, it's upstairs, but this is a very simple version, another one like this. So what we would do, we would put our sample in a tube, so something like this, and then we would put it in the machine, and we'll measure it, and we already like made a calibration curve for it, so it would spit out a predetermined number for us, and we just record it. Advice for to get involved in research, honestly, just like email out to professors, because they're very knowledgeable. The way I got involved was, well, luckily my first semester freshman year, I was in Trevor Boyer's ASU 101 class, and that was like the only environmental professor I knew at the time, so I emailed him. Basically all the environmental professors here do research, and you can just like look it up on like ASU, like the My ASU search for professors, and it also just shows them like what their research interests are, and that way you can like find one that aligns with you. I would recommend getting involved with research. I really like it. It's very enjoyable. It's different from like the classwork. It's a lot more work. You're like adding on another job. But it's nice to actually see like the concepts you're learning in class like apply like physically and onto like work that's going to be published and like read across like the career, I guess, the field.
Hi, so my name is Trevor Boyer. I'm a professor of environmental engineering. My academic background is I have a bachelor's degree in chemical engineering and a master's and PhD in environmental engineering. My main area of environmental engineering is as a faculty member in academia, and then the research I do focuses on water and wastewater. So as a faculty member, you teach courses, you direct students in research, you also do different professional service. So for me specifically, I teach undergraduate and graduate courses and different topics related to environmental engineering, usually related to water and wastewater, but can also vary. I direct undergraduate, master students, and PhD students in research. Again, doing all different types of projects related to water and wastewater. And then there's other kinds of professional service, like I'm an editor at a journal where I handle different manuscripts, find reviewers for those papers so that we can see if that work should be published, part of different professional organizations and committees, all kind of advancing environmental engineering in different ways. The good thing for me, or what I like, is that it varies quite a bit. So there isn't really a typical day or a typical week. Of course, each semester I teach different courses, so that has a big influence on what my day and week looks like. But research projects come and go. And so, right now I have a range of projects, quite a few of them related to phosphorus, some other ones related to emerging contaminants. So I work with students, have individual meetings, group meetings. We have meetings with the funding agency. So it's teaching, it's working individually with students, it's having a variety of meetings. And then again, there's different types of kind of professional service happening as well. Reviewing papers, attending committee meetings. Well, Well, of course, if you take ASU 101 with me, you get lots of good advice. I guess as an incoming student, I think it's good to, maybe first just sort of work on being a student, right? I mean, it's a transition, so go to your classes, learn the material. Then I would encourage you to get involved with a couple things. I do think students get into a little bit of trouble when they spread themselves too thin. So whether it's a student organization or research or an internship, I'd say find a couple things to get involved. Maybe try a few things in the beginning, see what you like, and then I'd say maybe focus, junior, senior year on sort of less things, but try to really do them well and get something meaningful out of that experience. We have this environmental engineering program, the bachelor's degree, so that students can get hired immediately with their bachelor's degree and have the skills that employers are looking for. But we also have courses like data science for environmental engineers, where I think if you look across the US, you're not likely to find that course in any other program. But I think future environmental engineers will be doing much more with data. And so that's a specific example of where I see the field going, needing more data, having to work with larger data sets, having some kind of, very kind of light, data science, computer science skills, I think is where the field is going and can help set students from our program apart.
Hi, my name is Natalie Miller. I was an intern for Waterworks 2 years ago. I did it my sophomore year, and even though I had only taken a few classes from EVE, I was still able to do data analytics and help them with the wastewater treatment design process for a couple different sites in different Arizona cities, and I really enjoyed my time there. And for applying for internships, even if you are a sophomore, I would recommend still doing it because you still have classes that apply, and you can always learn some stuff as you continue your EVE career.
We are quite literally just solving problems for people. That's it.
And
For us, it
honestly,
just so happens to be with water.
problems that I didn't even realize existed, like I never thought about what happens when we flush our toilet or when I turn on my faucet. Where does that come from, and how do we make sure it's clean, and how do we make sure it's at the right pressure, and how do we, just all the details. I just never realized that that's a big deal. And so it's fun thinking sometimes when I'm just get caught up in the details. It's nice for me to just take a step back and be like, hey, this is a necessity, and it's fun to be a part of making sure that we live the way we do without even really thinking about it.
Yeah, and I heard a quote that I thought was kind of interesting, is that wastewater is a silent industry, or maybe I'm not quoting it entirely correctly, but the idea is that you don't hear about our industry until there's a problem. So, which I mean,
That's
for
true.
sure.
Yeah.
Like if there's a big pipe burst or there's a big leak somewhere, that's when you hear about it. But
Yeah, people don't go to the faucet and say, oh, I'm so thankful for this every
Yeah,
day, because
yeah.
it's just so we're used to it. But
yeah,
we get to deal with wastewater, drinking water, water distribution. Some projects that I've worked on are rehabbing a clarifier. So that was, to do that, one of the aspects of that is it's kind of in the middle of the process. So I did it hydraulically from very beginning, from influent, follow a drop of water hydraulically through the whole process, and make sure that when I change that clarifier, it's not going to mess it up, it's not going to back up water, it's not going to make it flow too much or whatever.
So for me, the thing that I really like is the aspect of coordination with others. So you genuinely are working as a team, and at least here for environmental engineers, you more or less will lead that team. So the ball comes to you, and you are the one who effectively provides all the information to your electrical team, to your structural team, to your drafting team, and I like that aspect of it. I like ensuring that we all are moving forward together to create a good product. That's the part that I like about it.
And there's so much collaboration. I worked from home yesterday and I have a lot of questions about specs that I was like, oh, I can't wait to get back and ask Michael all these questions about specs. So
Oh boy.
it's super nice because his strengths are my weaknesses, and so it's easy for me to be like, oh, what do I say about
Yeah.
this pipe or whatever? Because in school we didn't learn about valves, we didn't learn about different pipes, and that is the bulk of what we do, and so
Yeah, it ends up becoming a lot of those finer details that,
Yeah.
like, for us, the big thing is the process stuff, right? Like, we learn a lot about aeration basins, oxidation ditches, and then, grit removal, solids removal, and just those individual processes, but we never really could dive into okay, hydraulically, how do we make this
the
work?
details.
'Cause,
So like in our work now, this is what we'll do. It'll be like, there's grit removal. How is that connecting to everything else? What are the pipes like? What's the slope? What's the valves? How is it gravity flow? Is it pumped? Like, there's so many details. And in school we just learned there's grit removal, then it goes to
Yeah,
here,
yeah.
then it goes to here. So we really get into the details of all. And with what we do, I don't know how it is at all consulting firms, but we get to have our hands in everything.
Mhm.
So we get to learn grading and drainage and civil and structural. We have structural engineers, so we don't do that, but we have to redline and check and make sure that, and electrical, same thing. We don't do it, but we have to coordinate with them, and mechanical, we get to do it all, which is made this first year hard. But yeah, I feel like we're getting a really good base in
Sure.
looking back on my first projects I've started. I
Oh,
did
yeah.
not know what I was doing.
Oh, yeah.
But now, like he's saying, because we learned so many different aspects in all the different projects, I look back at that first one and I'm like, oh, I'm getting what was going on then. Which at first I was literally just doing the spreadsheets, doing the math, not really understanding why or what. And now it's all starting to click and make sense, and which is super rewarding, because it's like, oh yeah, this makes sense. I know what I'm doing. I know what's happening here. I know why the water's flowing. I know why these valves are working. I know why these pumps are doing what they're doing, and just putting it all together instead of just seeing the math of it, because I would say engineering, what we do this much math and this much of the design. So, and all the rest of it is detail. I mean, that math has to be spot on.
Because that influences your sizing of everything, and it's going to ultimately influence how things are placed in your design as well. So.
Yeah, and it influences the flow. So if you don't have the pump right, people are not going to get water out of there, or
Oh, yeah.
it's going to back up the sewage or something. So that math is super important. But when I get a project, the first few weeks are the math, and then everything else is dictated by that math. But then it's like months of design.
Yeah, I
It's
think
literally something different all the time.
I would say where it really starts to become interesting from the design standpoint is once your project goes into construction. Because then you have somebody who is thinking from a completely different mindset of what you were thinking. Because they're thinking about, how am I going to build this? So then you begin to have that stream coming in too, that we, quite honestly, we just don't see, right? In engineering and in school, it's not something that we're thinking about. We're not thinking about, okay, how are we going to physically build this? How is someone actually going to put this quite literally
In
the ground,
life, how
right?
does this
yeah,
work?
how does this work in life? But yeah, you begin to see it from all points of view, and that's both humbling and very rewarding at the same time.
Yeah. So I feel like this job is I'm gonna say mundane because you're at your computer, but it's not boring because you're not doing the same thing at your computer every day. You're doing something different. And I really like site visits, so I like when they let us go out and take pictures. To me, it takes it off of the paper, and I'm like, oh, this is what's happening. This is what it looks like. So
Yeah.
I do like that part of it also, which Waterworks does great at, just getting our hands into everything.
Which is both terrifying at
Yeah,
first,
terrifying.
but also, I don't know, you see things that,
Never once have I gotten a job or never an assignment and been like, ooh, I got this. I know how to do it. every single time I'm like coming
You're like, I
back
have no idea what I'm doing.
deer in the
Yeah.
headlights, but then you just take it one piece at a time and
Yeah.
it works out. And like he said, this, I don't know how all consulting is, but here it's super collaborative. Like I could ask anyone, the owners down to the drafters, anyone, and they'll help me out with something that I don't understand. So that's nice.
I would say think about taking your FE after, I would say, your sophomore year would probably be a good time to take it. That was one thing that I waited on personally, and in terms of it's that step towards your EIT, which the EIT is a step towards your PE. It's more of a way of showing to potential employers that you're serious about engineering, is how I would describe it. Without it, you just don't have that clear path set out to your PE. And for me, I didn't take it until after I had graduated. But it would have been nice if I just, like, while I was in school, got it out of the way, because then I wouldn't have had to worry about it. And then you don't have to, like, think back, oh man, what did I learn freshman year? What did I learn sophomore year? You just kind of, it's all fresh.
Yeah.
My name is Braden Bennett. I am the operations supervisor of the Greenfield Water Reclamation Plant with the City of Mesa. Yes, so City of Mesa owns and operates, together with the Town of Gilbert and Town of Queen Creek, the facility, the wastewater plant, and Mesa is the lead agent there, and so therefore I work for a municipal wastewater plant. Basically, as the supervisor, I am responsible for overseeing the safety, compliance, and process of the plant. I need to make sure that everybody who comes here to work is safe. It is an industrial environment. You know, there's a lot of places where people can get hurt, so we got to make sure that our safety practices are being upheld first and foremost. We got to make sure that the plant is within compliance, so I have to oversee a lot of data collection and operations where operators are going out collecting data, checking equipment to make sure that we're driving the process in a way so we're maintaining our compliance set points, and that then trickles into making sure the process is stable. So basically overseeing the daily work tasks for all the operations staff, working with the maintenance staff to prioritize equipment that we need to get fixed or look ahead at fixing, scheduling equipment to come down for maintenance, doing a lot of administrative tasks like work schedules and time cards and things like that. Other things like analyzing data, looking at the logs from the previous day, reviewing all the flows, all the plant data with our SCADA system, and make sure that everything's humming right along and we're doing what we need to be doing. So for me, the bioreactors are the cool part. So the aeration basins and the anaerobic digesters. So when I was at ASU, I had the opportunity to do a little bit of student research in one of the microbial ecology labs there. The biggest change is actually probably more of a negative one. The average operator is retiring, right? So across the country. So there's actually a shortage of operators. And these are the people who have to understand how all the different plant processes work, not necessarily in excruciating detail, but in a level of detail that enables them to prop up the process and make independent decisions and independently solve problems throughout the whole, every process area of the plant. And because we're losing a lot of the older operators who have that lifelong career's worth of knowledge, it's not necessarily getting passed on to newer operators. So I would say the biggest challenge that we face right now in the water field, and this is drinking water and wastewater treatment, is finding people who are interested in the career field, want to stay in the career field, and are able to be trained and retain that institutional knowledge that is now starting to dissipate. So that's probably the biggest industry change I see as far as like the workforce and the labor force. And it's a stable job. It's actually a very stable profession. Working for the city, a lot of benefits as far as like pay and medical benefits. And yes, I'm shamelessly plugging working for municipality. But it is, at the end of the day, it's a great career field. It's interesting, it's stimulating, it's important, it's critical. All of my operators are rated as critical essential staff, which is a rating that's only shared by police and firefighters. So water workers actually share the same importance as employees in the eyes of the city, compared to like other career fields. It's not that they're not important, these are critical jobs because it's critical infrastructure. So there's a lot of, it's a lot of stability, in this career field too. Aside from it being totally interesting, so, yeah.
It's not an easy career. It's difficult because of the stresses that can be put on you in day-to-day operations in an industrial facility. It's either increasing or decreasing production. You're going to have change. That drives, we call it churn. So there's lots of churn day-to-day. From we're bringing in a new product, we need to permit these, and we don't have emissions credits, so we have to either buy them, or we have to offset, or working with permitting agencies to have breakdown, we can get people in to fix it, depending on your facility that you're working at. Or we've got a regulatory inspection, or we've got 2 regulatory inspections the same day, and how to deal with it. So it's very rewarding in one part, but it's also, like we mentioned before, it can be very stressful, and it's something you need to be prepared for, as far as having certain demands put on you. You've got to jump through hoops to get those things done, because the company or the corporations depend on you to get that done. So, but it's also very rewarding.
I mean, I guess my big thing is being a T-shaped engineer, and so that means you need to have, you think of the capital letter T, you need to have expertise in an area, so that's probably initially environmental engineering, and then as you advance it may be drinking water or wastewater or urban air quality. So that's your expertise, but then I think it's really important to have breadth, right? So across the top, I mean, and you can choose what that is, right? Whether you want to expose yourself to policy and humanities and urban planning, or whether it's, you know, data science and coding, but I think you need to kind of build yourself broadly so that you can take that expertise and work with different people.
Yes, I would say stick with engineering, first of all, because engineering is always useful, you know, and specifically environmental engineering is going to be focusing, and alongside civil engineering as well. But I know environmental engineering has that focus on things like water treatment and wastewater treatment, and humans don't do well without water. You know, they don't do well without water. You know, as recently as about a century or so ago, you know, we were still having issues with massive public health epidemics as a result of not being able to treat sewage, you know, in all, you know, urban areas. So it's a public health importance, you know, to be able to do these jobs. So stick with it. So stick with being an engineer, learn whatever you can. Don't be afraid to get out and do non-engineering things, you know, get out there and find internships or job opportunities, or even just, you know, small brief experiences where you can get like a fresh set of eyes on everything. The broader you make your understanding of how all of these complicated systems work, the better you'll be served in your career. You'll be able to provide more insight. You'll be able to provide more, you know, value to these, you know, complex projects. Whether you get into the design side, whether you actually end up going into like an operations field or something like that, whatever your career path will be, stick with engineering. It's I know it's hard. It's worth it. It's interesting and it's useful, and there will always be a path for you somewhere, wherever that path would be. So, but along the way, take in as much as you can, you know. So there's a lot to build upon that'll make it, you know, successful for you. So.
And actually, try to find a mentor, somebody
Yes.
who's already in the industry. There's lots of us out there that would be more than willing, just like this interview, to come out to help and provide guidance and direction on maybe what to focus on, or even find connections with the right people already in industry, so you can find out if that's really what you're thinking, that this career is where you're gonna end up.
Thank you so much.
You got it.
Yes,
Hopefully that was
thank you.
good.
That was perfect.
That was the only time I've ever given an interview.
Yeah.
I don't know if I said my last name. Georgie Anderson.
Way more than you think you need to. Good call.
Wastewater. We're still trying to clean up the environment. We're still trying to make sure that we're protecting it, and so.
Go Devils.
Yeah. So if you know anybody, we're hiring. Yeah.